Indifference, who's all the way from Sydney, Australia. We're in the Dallas area, and we're going to be doing a book launch party tonight for our Story of the Cosmos book. I say ours. We wrote together one chapter in the book, but I think I definitely would recommend many of the other chapters as well. It's got a number of different focal points within it. It's not just hardcore science, but it tries to deal with literature, history, different things like that. But our chapter is more evidential in nature. It is dealing with fine-tuning and looking at, can you make it into an argument for God's existence? So we want to take the opportunity to talk to Luke here, and I can chime in a few things myself, but I was very much honored to play some small role in this book. It's a pretty incredible book with some great authors such as Dr. William Lane Craig and Dr. Michael Ward from Oxford. So you guys should check it out, see what you think. But Luke, what are your thoughts on this book? And
yeah, it's a wonderful book. In particular, one of the great things about being an astronomer, whenever you give a talk, is you have all these wonderful pictures of the universe that you can actually show. And it's very easy to make the greatest, most beautiful PowerPoint presentations you've ever seen. And the book is glossy the whole way through, and so there's these wonderful pictures in high resolution all the way through, which is, if you're going to tell a story about how beautiful the cosmos is, putting those sort of just mind-blowing, yeah, that was great, mind-blowing pictures in there is really great. And just looking through the authors, people who have written and thought deeply about these sorts of things, covering an awful lot of different of topics. So yeah, the book looks great.
Great, yeah, we're so thankful that you were writing a chapter here, that we were able to do this together. So one of the way that we start off the chapter, I think it was your idea, and I thought it was excellent to look at a quote by Richard Dawkins.
Yeah.
And I guess I'll read that here since I have it in front of me.
Yep.
The universe that we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. DNA neither knows nor cares, DNA just is, and we dance to its music. That's from River Out of Eden. And as usual, Dawkins is a very articulate person, and I think he is appealing to an important principle here, that when we're evaluating candidate worldviews or theories or whatever, we're looking at what are the predictions, what would it look like if this were true, let's compare it. So we do want to compare theism versus naturalism in terms of what does the universe look more like the kind you expect under naturalism or theism. And what are your thoughts then about this Dawkins quote?
So I quite like it it's Dawkins, so it's lovely and clear. And just the idea that there are things you expect to be true if like Dawkins, you have this worldview in which there is at bottom no design, no purpose. So it's not the case that you just sort of, you're not just agnostic about everything. It does actually generate expectations of what we would expect the universe to be like, and we can then go and check those. The thing about that quote that strikes me, especially as an astronomer, is that he's talking about what the universe is like at bottom, and then he starts talking about DNA, and this is a point we make in the book. In our chapter, that DNA is not at the bottom. I mean, if you're going to talk about what the universe is like at bottom, I don't want to start too much of a turf war here, but you're talking cosmology and physics and those sorts of disciplines, and DNA is an important part of the story, but it comes later and more locally.
And so it turns out that, as you know better than I do, that some of the elements in DNA, some of the kinds of atoms that we need, such as carbon and oxygen and hydrogen, there's various fine-tuning aspects in which it's quite possible that stars would not have generated carbon or oxygen or both in any substantive quantities. And so, in particular, it seems that fine-tuning has something to say about what Dawkins is trying to evaluate here. Do you want to elaborate some on?
Yeah. So one way we could try and get a handle on this, like what sort of universe would we expect? Let's just try to sort of pick one at random if you're a naturalist. So I think that's what Dawkins is trying to sort of get at, but one way of doing that is let's take the sort of fundamental properties of the universe as we know it, the best we've learned, and let's just try and pick some of those at random and see what other universes we could get out there. And so you're saying DNA needs all these, it obviously needs the elements it's made of, and those need to be produced mostly in stars. Certainly all the heavier ones do. And so we can ask whether, how do we get a universe which has these elements in them? How can we make them in stars? How can we disperse them throughout the universe? And so when we start to change these numbers, we find that there are various ways in which you can kind of ruin the universe. Given the theories that they're in, we sort of have a range of values that we can go and explore, and in so many of the cases we find things happen like, just give a few examples. So the three basic fundamental particles that all of DNA is made of at a fundamental level is the up quark and the down quark and the electron. Just if you want to write those down for later on. And we can think about how heavy each of those particles are, and that's one of their basic parameters of mass. And what if we change those numbers? And it turns out there's a whole lot of disasters. You can make universes in which the only stable element is hydrogen. And so all of the wonderful chemistry of the periodic table and all of biochemistry and DNA, Dawkins, DNA doesn't know or care. Well, it's not even there if you only have a universe with hydrogen. But that's a very easy universe to create. Or one that only has neutrons, or ones where stars don't burn, or there's a whole lot of other things like that. So actually, a universe at bottom isn't going to have DNA in it at all, which is at bottom, no purpose, no design, is going to have no life and nothing to make DNA out of in the first place.
Is it fair to say that nearly all of the fine-tuning aspects of the fundamental laws, really almost all of them, maybe not quite all of them, but would prevent the ability to have DNA in any kind of abundance?
Yeah. So as physicists, as astronomers, I'd love to be able to start with the fundamental, equations of how matter works and just derive that DNA exists. We're not quite there. We sort of piece things together bit by bit. We know how quarks combine into protons and electrons. We can see how they combine into quarks into protons and neutrons. They combine into nuclei, and then nuclei, the electron goes around inside to get atoms, and then those combine. So we can sort of build things up piece by piece. And when we think about fine-tuning, we're really thinking about, can we take the basic stuff of our universe and make any sort of stable, complex thing? Anything right. that can be built out of the smallest pieces. Yeah,
we probably should make sure that the audience is clear that obviously you could have things other than DNA in life. I mean, even other than carbon. So really a lot of the fine-tuning is still at a much more fundamental level of just, is there a complex, organized structure that's able to exist? And in particular, sometimes people think that, well, the fine-tuning advocates have just not been open-minded enough about different kinds of life.
Yeah.
And maybe there's other forms of life possible. So we try to address that in the book, referencing the work, for one thing, of John von Neumann, who showed sort of with some mathematical rigor that even for things like cellular automata, which exist in computers, any kind of self-replicating system is going to need certain properties in order to store information and to replicate it. And in fact, he did his work prior to us really knowing about DNA, and it turns out DNA was really following the whole replication process in different aspects. Life was following the same model, which I think it almost has to be if we understand his work properly. And so what we're trying to do in the book is show that minimal requirements for life can rule out things, even if we're not real sure of even how to define life. Biologists might differ. Please elaborate on that. What are your other thoughts in terms of...
Yeah, so a lot of these, let's go change these numbers and see what happens. A lot of these other universes turn out to be really simple. It's really easy to work out what's going on there. So for example, if the only element you can make is hydrogen, then all of the complexity of chemistry, all the rest of it, the chemistry textbook, we don't have to worry about that anymore. Or if you have a universe which expands too fast for galaxies to form, then you don't have to worry about the hard bits of galaxy formation, which we try to do with supercomputer simulations and all that sort of stuff. You don't have to worry about any of that stuff. No galaxies form. You can solve the equations with pen and paper. They're very simple structures. Some slight lumps and bumps in the universe, but that's as much as you ever do. And so the point is that our universe is hard and complicated, and there's some bits that sort of really hard to understand, and life is one of those bits that's hard to understand. But these other universes that we find when we change these basic numbers, those are the easy ones. Those are really simple to look at and see that nothing complicated happens.
Thanks, Luke, for your interview, and we'll continue with part 2 of this video as we talk about the cosmic coincidences of fine-tuning.